Hello everyone. In this video, we will learn about a rule through which we can find some probabilities using a probability tree. I will call a probability of a path, um, and we will see in first in one simple case, and then the generalization of rule will be given there. Okay, so consider the following probability tree. Okay, so here what we have is yes. Okay, now the numbers that we have here are probability of A, and here's probability of B knowing A. Probability of B knowing A, let me write it in black. Probability of B knowing A, remember the formula for this. This is probability of the intersection divided by probability of the known part. Now, if I multiply this to the other side, I'll get probability of intersection is equal to probability of B knowing A times probability of A. And you see that probability of B knowing A is given on the tree. Probability of A is also given on the tree. What this says is that the product of these two guys is going to give us the probability of intersection of these two. And that is the rule for probability of a path. So it says that product of the probabilities on a path here means from an end point to the root, or terminal node to the root. So you multiply all the numbers you see on the labels from a terminal point to the root is equal to the probability of intersection of all the events of the path. So in other words, whenever you want to find probability of intersection of paths, for example, see probability of, let's say, A complement intersect B complement would be whatever you see here and whatever you see there, you multiply those two, and that will give you the probability. Or probability of here, let's say there's a number there, so probability of B, see the path here contains B and A complement, so B intersect A complement is going to be equal to product of all the numbers from that terminal point to the root. So triangle times circle. Okay, so that's the rule through which we can find probability of intersections of events on a path. Just multiply all the way down to the root. Okay, so let's see this in some examples. So you remember the example that we did in another video for box of balls. There was 3 containers, each one had some numbers of red and black balls, and we made that tree there. So now we have that tree, and we want to find the probability that the jump ball is a red ball from first box or first container. So here we are trying to find probability of first box and red. First box and red is this is probability of a path which contains C1 and R. An intersection of those ones, by the rule, is that you have to go find that one. So this is the path, and then you multiply the numbers along the way. So 4/9 times 1/3. That together is 4/27. Probability, that's the first part. Probability that we get black from the third box. So C3 and black. C3 and black is this path here. The intersection of all the events on this path, B and C3, the probability of that is given by the product of the numbers you see along the way. So 5/9 times 1/3, which is 5/27. Okay, so that way you can use the tree to find the intersection of the events which form a path. Okay, how about this other example? This was another example that we did for in one of the videos, and this is, well, you don't need to do that example again. Here what matters is that we have the tree, and now we want to see if we can use those ones to evaluate some of these probability that parts are defective and the machine is set up properly. So we are trying to see what is the probability that we get defective and properly set up. Defective and properly set up. These form a path, so the probability of the intersection is going to be product of these guys. 0.02, which is 2%, times 0.9, which is 90%. And then when you multiply, you get 18, and that will give us the probability that the effective part comes out and the setup is properly is 0.018. Okay. How about the second part? We are trying to find probability of the part is not defective and is not set up properly. Okay, so in that case you have this one here. So again, you multiply all the numbers there. 0.8, which is 80%, times 0.1, which is 10%. Together 0.08 or 8%. Okay, so as you see, this is a simple rule. Probability of a path, product of the numbers on a path is equal to probability of the intersection of the event on the same path.